Welcome back to the next episode of Blind75. Today we are looking at the sixth problem, which is remove nth node from end of the list. Let's take a look at the problem. It says we are given a head and we need to remove nth node from the end of the list and return its head. So if you look at this example, n is 2 and we have to remove the second node from the end, right? So we need to remove the node 4. Okay, so in the next example it has only one element and we have to remove the first element from the end, which is 1 itself. So we should return empty list. Here we have 1 and 2. We have to remove the first node from the end, which is 2. So we have to return the head of the list, which contains only 1 here. Let's take a look at how we can solve this problem. I hope you already know about what is linked list, and if you can imagine you have a chain, and but you haven't seen the end of the chain. You only know the start of the chain, that you have it in your hand, which is in this case the first element. So you only know 1, so you don't know the length of the linked list. So how do we remove it? So what we could do is iterate through the linked list and find the number of elements, which is 5 here. And what do we need to do? We need to remove 4, because n is equal to 2 here. So we have to remove second and third. So when you remove 4, what should we do? We should link the third element with the next element, which is next element of 4, which is 5. So this is what we need to do. So once we go through this, we know that the length of the linked list is 5 and we need to remove 4, right, by linking 3 directly to 5 and not to 4. So we are breaking this link here. How can we do it? So once we go through or iterate through the list, we got the total length as 5 and we know n is equal to 2. That means what do we need to do? We need to link the third node here, which is 5 minus 2. This is n and this is the length of the linked list. Okay, so this is one way of doing it, right? What is the complexity here? So we do an iteration first to find the length, which is order of n, and then again we do iteration to find the third node and then link it with the fifth, the node 5 here. So that is again order of n. So the complexity is order of n plus order of n, which we can say it is order of n or 2n or order of n. Okay, so let's try how to implement it and then we will come back and see if we can optimize it. Okay, so so what do we need to do first, right? We need to find the length of the linked list. Okay, okay, so there is an edge case, right? What if okay, let's see if there is any constraints. Okay, so it is telling that it is at least there is at least one element in the linked list. So the initial head is not an cannot be an empty, so we don't need to handle that. So the value could be somewhere between 0 and 100 inclusive, and yeah, the length is okay. Yeah, the n is between 1 and the size of the linked list. So we also do not need to take care of cases like where n is greater than the length of the linked list. So we'll stick to what we have, and there's a follow-up as well, which will come back later after we have done this. Okay, so let's what do we need to do? We need to find the length, right? So I'm going to define length as 0 and I'll declare a variable called node, which is initially set as head so that we don't lose the reference. So while node, we'll keep iterating node equal to node dot next. And what do? We will also keep updating the length. So at the end of this loop, we will get the length. Okay. Then what we need to do is we have to do this operation to find which, like from the start, which is the node to delete or to change. Okay, so I'm going to do length is equal to, we are going to remove n from length, so it would become 3 in this case. So then what do we do? So let's okay, let's take a start element. Start equal to what? Start equal to okay, sure. So I'll do a trick here. I'll create a dummy node. Dummy node is equal to, we can give any value. Sorry. And then we will say that this is head. This is to make it easy. I'm just thinking whether I want to complicate this, because okay, so yeah, let's try this, and I hope you you understand how this works. So I'm creating a dummy node. It can be 0 or -1, and then start getting to this particular node, which is 3 here. Okay, so okay, so start is equal to dummy, and what do we know? We know we need to manipulate the third node from here, right? So while length is greater than 0, we will keep decreasing the length, and we will move start is equal to start dot next. At the end of this while loop, we will be at 3, right? 1, 2 and 3. So yeah, so what do we need to do? So we need to point this to the next one, right? So we can do start dot next is equal to start dot next dot next. So we are just basically removing this and removing this next link and linking it with the next to next. So we do this, and we need to return the head, right? So you know that we created a dummy node, so the next node is dummy dot next, so we will return that. Yeah, so I think this is done. Let's see how let's see if this works. Oh, okay, so it worked. Let's talk about the complexity here. So this is order of n, and this is order of n as well, right? So order of 2n, which is approximately order of n. Then what is the space complexity? So we are using this dummy element to tackle the edge cases. So this is a constant space. So let's submit this and see if it passes. I'm not so sure because it's a 2 pass, so we will okay. So runtime is 55, beats 22%, beats 37%. Okay, can we do better here? We can. How? I'll explain how. Let me reset the canvas and then we'll write. Okay, so we have 1. I'm taking the same example. 2. Here I will not use a dummy node so that it's clear. You can do it with or without using dummy. So if you don't use a dummy, that means you need to handle the edge cases separately. Okay, so we'll instead of one pointer, what we will do is, so here n is equal to 2. So we'll use 2 pointers here, right? Let's call it as slow and fast. Okay, so what do? We will iterate the fast pointer n times. So 1, 2. So first fast is head, then 1, 2. So fast will be here initially. Okay. Then what we will do is we will start iterating slow element from the beginning and also move the fast one forward. So small will be here, right? And in the same iteration, slow will come here, then f will come here, then slow will come here, f will come here, and so on, right? So so we will hit this element. So this is the one that we need to manipulate. So this is the one we need to delete. Then we will do the same operation by linking this with this. So this is a bit better than the previous approach. So we kind of do only a smaller number like iteration here and then handle. Okay, so let's code this. So let's set slow as head, fast as head, then so let's for I in range of n, we are moving the fast one, fast dot next. Okay, so we moved fast, then we will iterate until fast is not null. Okay, so 0 and then 1. Okay, so yeah, we move fast and slow is equal to slow dot next, fast is equal to fast dot next. Oh, we missed something here. Okay, so suppose we when we move and while fast we keep iterating fast, right? So we hit null here, fast dot next, then the start is going to be at the node which has to be deleted. This is how it is going to be. So how do we link 3 and 5? So for that we need a reference to the previous slow pointer. So we'll do that while we iterate. So we'll do slow previous is equal to slow. So initially previous will be none. So we haven't done that. So let's set it as none. And when slow becomes 2, previous will be 1. When slow becomes 3, previous will be 2. When slow becomes 4, previous will be 3. So that we can link 3 and 5 here, right? Okay, so this is what we did. Okay, so we have to handle, so I'm not using any dummy element here, so we have to handle the edge cases, right? What if the say in this one we are asked to remove the 5th node from the end, 1 2 3 4 5, right? So we might have to remove this. So this is an edge case that we need to handle. How do we know whether it's the first node to be deleted or not? So initially we have set previous as none, right? So if it is the first node, previous would be none. So we will check if it is previous. If there is previous, what we will do, previous dot next is equal to slow is what? Slow is 4, right? Slow dot next, and then we will return the head because we are not deleting head. Else, that means we are removing the head. Head is getting deleted. In that case, what we would do, we would just return next head dot next, because we don't need to care about anything. This is head, we will just return this. So this will become the start of the linked list, right? that's it. So let's try running this and see if we missed anything. Okay, it passes. Let's try submitting it and see how it goes. Yeah, so it beats 71% of the users with Python 3. um, since we use these many variables, the memory is 5 point, yeah, beats only 5%, 5.13% of the users. It kind of changes, and also based on the time that we execute, but this works. Okay, so that is the end of the sixth problem from Blind75, and I hope you like the solution and you understood the solution. Yeah, so basically the first one we did with the two entire pass, and the second one we did it with the one pass. Okay, so that's the end of this video. I hope you liked it. Please let me know how did I do in the comments, and please give me feedback so that I can improve. um, yeah, also please subscribe. I'll try to keep adding new videos every day. And thanks a lot for watching. See you again in another video. Thank you so much. Bye.